as important. Fourier transform. So if you have a relation, you can actually get the transform equation, and I'm going to give you that relation which is most commonly used. And there are different ways of representing it. Okay, sometimes you will see the books which basically have 1 by 2 pi there. Okay, and if that's the case, the Fourier transform relation will also accordingly change. Okay, but then I'm just going to stick to this particular relation. When we write down the Fourier transform, is equal to 1 divided by root over 2 pi, okay, integration, and then we actually go from minus infinity to plus infinity. That's the entire idea of having a Fourier transform, because you can actually have limit from minus infinity to plus infinity dx e to the power I k x fx. So you have to kind of remember this relation. Okay, this is again important. And then we actually have the inverse Fourier transform. Okay, inverse Fourier transform. And if you remember both of them, whatever you need to memorize is done for this particular point. So inverse Fourier transform is nothing but we are just replacing the variables here. We do have x, okay. So now this side it will be fx, and then on this side I can actually write it down to be 1 divided by root over 2 pi, okay, integration of minus infinity to plus infinity. In place of dx, it would be dk e to the power, this would be minus of I k x, since we're talking about inverse here, okay, and then this would be fk. And that's called the inverse Fourier transform. So we're going to look into different numerical problems and going to check how we are going to use the Fourier transform and the inverse Fourier transform. So it's all about doing integration. Okay, if your integration skills are good, this should not be a big problem. Okay, this should be something which you'd be able to do. Okay, so what we can do is probably we can just do few numericals. Okay, and based on that we can actually understand how to use these formulas. Okay, so whenever you actually have a question on Fourier transform, you will have something like this. Okay, most of the times. Okay, the questions will be something like this. So for the first one, let's just write down the entire question, and then from next time we are going to write down the problem that we have in hand as we know this. Okay, so find the Fourier transform of. So your problem will be something like this. It will be written as fx. Usually it's written in small f. Okay, small letters. 1 and 0, and then mod of x lies between, I hope you understand this, and it is mod of x greater than a. So this one I hope you understand. If I write down mod of x is less than equal to a, it means that x will actually lie between minus a and plus a. Minus a and plus a. In integration, this equal to sign doesn't carry much sense. We're just considering the entire limit here. So it's minus a plus a, that is more important. And for the other limits, okay, for the other limits, maybe this, and if it lies between a and infinity, that is 0. And that is why we've written it like this. Fx is equal to 1 and 0. Okay. And what we need to do is one more thing, where we are actually going to use the inverse Fourier transform. So let's just understand the question first, and then we can actually proceed with the solution. Hence, evaluate. Okay, you can do it easily. Okay, it's not difficult. The thing is, you have to just put the right formula the right place. That's it. So we can do as many sums as we want, but then all you need to just practice, do it a bit more in detail. Sine of lambda a, and then cos of lambda x is not subscript, this is divided by lambda b lambda. This is something which you have to do. So for doing the second part, actually you need to use inverse Fourier transform. So it is going to use that. Okay. So since we have the question now, maybe we can just try to solve it. Okay. I will just solve it further and solve the problem on Fourier transform. So maybe we can just do it slowly. So let's try to actually solve this problem. So to find out Fourier transform, I'll just simply write it down as f of k is equal to 1 divided by root over of 2 pi. We're going to use this. So we have got dx e to the power I kx, which is fixed, fx. Okay, so fx is something which is there given by the function, right? But this particular function, I will just do it in short. You can actually write it down. If this is from minus infinity to plus infinity, that means you can just divide the integrations from minus infinity to a plus of 1 divided by root over of 2 pi integration of minus a, sorry, a minus a, right? Or sorry, just take it on this side. Minus infinity to minus a, and then I can go from minus a to a plus, again I'll be taking 1 by root over of 2 pi, but the limit will be nothing but a to infinity. Right? I'm just not going to write down the bracket terms. I think you can write it down on your own. Minus infinity to minus a, the function is 0, right? The function is 0. So this term will actually become 0. So this is 0. And from a to infinity, again the function is 0, fx is 0, and we do have an fx in Fourier transform. So that means this term will also become 0. So whatever we left out is to evaluate what is within minus a and plus a. Right? So we can just take it to be, now I'll just write down it in detail. 1 divided by root over of 2 pi. 1 divided by root over of 2 pi. Okay. And then this is minus a plus a. And this is dx. So I'll write down the dx later. E to the power I ax. Right. And we have got fx dx. Okay. Now it turns out to be a normal integration problem. And then we can just take it out to be 1 divided by root over 2 pi, and then minus a to plus a, e to the power I kx, e to the power I kx, and fx, right? So fx is 1, so minus a plus a, fx is 1. I can just put 1, and I can just write it down to the dx, right? And you can do it in any way you want. Okay, you can just simply do it in terms of you can take I at the bottom and do it in simple terms. Okay, but then I will just do this in breaking up this into cos and sine because we will need it later. And we'll just practice it once. Okay, so e to the power I kx can be written as cos kx plus I sine kx. Okay, dx. So we have my relation like this, and then what I can do is, I can just see this is basically nothing but an odd function, right? This is basically an odd function. So if you just integrate it from minus to plus a, this is going to be 0. Right? So this is an odd function. So we are going to just do these things fast. We are not doing a maths class, so we don't need to do it in a very detailed way. But then we need to do few tricks. If you remember, it's good. If you don't remember, I'll just try to revise this for all of you. If it's an odd function, sine is an odd function, it will be 0 if you're basically having the limit from, let's say, minus a to plus a. So you have to just check it. You can check it on your own. And this is actually an even function, right? So that means that, if you integrate it, you are going to get the twice of that value if you just change the limit from 0 to a. So what I will do is, I will just change the limit. This is usually do it in maths, okay? Just to make things simpler. If I just take it twice, 0 twice, then this limit will not go from minus a to plus a, it will go from 0 to a. Okay, if you do it, even if you don't put this twice and do a sum, you're going to get a 2 in front. But then, I want to do it fast, so we have to, these tricks should be something which should come naturally now, because it's important for, mathematical physics. You cannot take so much of time. It's important, okay? Even for a normal pass exam also, you cannot go into so much detail, okay? It's going to take a lot of time. I prefer you all practice this that way. So then I can take it to be 2 by root pi. You can just rationalize and simplify it even if you don't do it. And then we have got this as sine of kx divided by k, and then I can take it to be 0 to k. Right? So if you can do it in any other way, it's fine, no problem. But then I'm doing it this way, so it's also k divided by 2 pi. Okay, and then
The
this is
answer,
yeah,
answer is root over 2 by pi into sine ka by k.
okay, right, yeah. So that's correct. Okay. So all of you have to practice it. You should actually get that you are actually getting this problem. Okay. So this is your transform. So practice is important, and whenever you are asked to find out the Fourier transform, you're supposed to get a relation something like this. So as I told you in the beginning of Fourier transform process that this kind of relation actually helps us to actually divide a signal into its components. We do need some mathematical tools for this, and for such tools we use something like Fourier transform, Laplace transform, and all. Okay. Now the next part of the question is we will have similar problems. That's why I'm just showing this in detail. The next part of the question is actually you have to find out this. Okay. Let's try doing this now. So what I will do is for this, I will first write down whatever was the Fourier transform that we got. So the Fourier transform that we have is f of k 1 divided by root over of 2 pi, not 1 divided by, it's 2 divided by, okay. And then we have got sine of ka divided by k. We will use this, okay. And inverse Fourier transform, I'll just write it down in short IFT, but for you, I'll just never do that, okay, in exams. Probably it's not a good way to answer. 1 divided by root over of 2 pi integration of minus infinity to infinity e to the power I minus I kx f of k dk. So what is my k? K is the Fourier transform. And what is the value? We have already found it out. So that means if we use the inverse, okay, we should be able to get the original function that we have. But we're not going to do it because we have to prove something else here. Okay, we have to prove something else here. So let's try doing that. Okay, so what we're going to do is we are going to write down in the other way. So what we can do is therefore we're just going to use the inverse Fourier transform now. Okay, let me write it down here so that you are not confused. Using inverse Fourier transform. Okay, so don't mix it up. It's very important that you write it down correctly. And when you practice, do it slowly. Once you know practicing it, you will see that you will actually gain that pace to do it fast. IKX, and then I will write down my FK. FK is this, so I will just write it down as 2 divided by root over of 2 pi into sine of KA divided by K dk, okay, is equal to fx, okay, is equal to x. So what does it mean? It means that fx was the original function, so 1 0, okay, and x is less than equal to a, and then x is greater than a. So you know, if I really don't show this side, the logic here is that if I take the inverse Fourier transform, that means if I do this and I use the Fourier transform here, the final result that I'm going to get is this. If someone tells me that show using inverse Fourier transform that you will get fx, so you can show it. But here it's not the question. The question is you have to prove a relation. In this particular case, you know, you can also prove it this way that using inverse Fourier transform, if I don't use this, let me say this side is a question mark, I don't know what is it. You can solve this and you will see you are going to get this relation. Okay, but anyway, we're going to do that later. We're not going to do it now. Okay, the question is what exactly we are supposed to show. Okay, that is again important, and that is actually a problem if they're doing it, you know, in different pages. I really can't. I don't want to go back to the previous page. I'll just write down the result. It's very important. The result that you are supposed to show is this, right? The result that you are supposed to show is minus infinity to plus infinity, okay? And this is a sine of lambda a and then cos of lambda A divided by lambda t lambda. Okay, to show this, okay, you have to evaluate this. Okay, you have to show that what is this equal. Okay, so that's the question. So for that, we are going to just look into the this here. When you look here, we'll just break it up. Okay, break it up. This is actually a trick which you can use in a number of sums when you are asked to evaluate. Okay, sometimes they will say that show that. There also you have to use the inverse Fourier transform and so on. So here, this e to the power minus I kx can be written as cos of kx plus I sine of kx. Okay, and then maybe I can just let me just simplify. Root over 2 pi into root over 2 pi would be root just 2 pi, right? And then on top we will have a 2 here. This 2 will get cancelled. I'll just have 1 by pi, right? Simplify this part, and then I can just write it down to be sine of ka divided by k dk. Okay, so this is one relation that we actually have. Then let me just put 1 and 0. I'll just keep putting on this side. Okay, we will just write on the other things later. Now if you look on this side, okay, if you see this side, what we have is there is no imaginary part. Everything is real here, right? See, there is no imaginary part here. So in general, we can say that imaginary is 0. Okay? The imaginary part, rather, I should say, is 0 on this side. So, in these kind of problems where the terms are independent of each other, the imaginary part and the real part can be equated. So, what is my imaginary part here? This is my imaginary part. So, if we equate it, it should be 0 because there is no imaginary part on this side. Okay. So, maybe I can just write down in one line imaginary part on RHS is equal to 0, right? Hence, I sine kx is equal to 0. So it directly vanishes. Okay, I really don't need to do this evaluation anymore. So again, it will become more simplified. I will just simply have it as 1 divided by pi integration of minus infinity to plus infinity cos of kx sine of ka divided by k dk. Okay, is equal to 1 0. This is mod x less than equal to a, and this is x greater than a. Now you see, very simple now. I hope you understand it now. This is the variable here, which is lambda now. Lambda, it becomes d lambda. That means what we can do now is put k is equal to lambda. That's it, right? If the variable changes, you have to change the d term also. So dk would be nothing but equal to d lambda. If we do that, we can simply write it down as minus infinity to plus infinity cos of k lambda. Sorry, not cos of k lambda, cos of lambda x rather. Cos of lambda x, okay, and sine of lambda a. Sorry, this is a, yeah, correct. I think I just mixed up something here. Sorry, this is x. Sorry, this is lambda x. Cos of lambda x. Okay, to show that whatever you're going to get, that is something which you have to show. This is sine of lambda, that's fine. Divided by k. So what is this is my k, which is nothing but lambda now, and dk is d lambda. See, we got this, right? And we have got a 1 by pi here, so we'll just cross multiply it. So the answer would be pi and 0, and this is actually nothing but x less than a, and then x greater than a. So this is how I prove it. So why I have done this in this much detail. The sums also I prefer to do it in detail. But if you're given a question on Fourier transform, and suppose you are supposed to prove something, you usually take the inverse, okay, and then show this is equal to the function itself. and do some adjustments, and finally you should be arriving at the result. That's the trick that we use most of the times. Okay. Let's take one more sum. These kind of problems, you cannot just have one sum, solve it, and say that you know the entire thing. It'll basically take a lot of time. So you have to practice on your own also. You need to see a lot of problems. There will be a lot of problems. If you check B.D. Gupta, I've seen there are a number of problems. And Rajput doesn't have too many problems. Most of the problems are unsolved. If it's unsolved, it's even better. You can actually try it. Solving 1 minus x square. This is modulus of x less than 1. And then this is 0. This is modulus of x greater than 1. Okay, and here also we have to prove. Okay, what we have to prove? Prove that okay, we have to prove that 0 to infinity. Okay, let me just write down this x cos of x. Okay, minus sine of x. Just look into this problem. Okay, divided by x cubed, and then we have got cos of x by 2 dx is equal to minus of 3 pi divided by 60. Okay, so you have to basically prove it, right? So first thing is solution for this fx, which you can actually find out. Okay, so let me just give you a, let's say 5 minus 1 to plus 1 I sine of kx into 1 minus x square dx. Let's bring it at one go, because it's nothing but e to the power I kx, which is cos x plus I sine kx. So I've just separated them out. Okay. So you can do it in different ways. You can just look into the limit and straight away say that of course it's and so on. Okay. But here it's minus 1 to plus 1. We are here. And when we separate out, we see that it can be divided into the cos term and the sine term. Here we basically have this cos as odd, this is odd function, and this is an even function. So we basically just do the integration here, whatever result we are going to get 0. Okay. And this is even, this is also even. We are not going to get a 0 here. In fact, you can change the limit here, minus 1 to what can be taken as 0 to 1 and multiply by 2, right? So we just do it that way, and then that way actually everything becomes more simplified. Divided by e to the power of 2 pi, 0 to 1 is 1 minus x square, and you can just have a cos of 2x. We have it now, okay? And then we can actually get x equal to 2 divided by e to the power of 2 pi. Okay, and if you just do this, you have to do the integration by parts. And this is the first part, so this is 1 minus x square. So first function into integration of the second part. To integrate cos kx will be integrated into sine of kx. Okay. These have to do what we do. So this is something which I just taught in practice. And then we have to go to the next integrating term mode. And there we actually have got 1 minus x square dx of 1 minus x square. So this will be nothing but minus x dx. And then again we integrate this the sine of kx by 3 and dx. And then for this entire thing, let's do this everything is considered. So again here also you can just put out the limits and everything, but then and minus will become plus, this minus and this minus will become plus. 2 I can take it out, 2 I can take it out, 2 divided by 3, and again x sine k. So again 2 times x will be there, and when integrate the sine kx, so it will be cos kx divided by k. Then we are integrating the part. So integrating sine should be a minus one, so it will be a minus. You have got a minus. When you integrate the part, the second part is minus, and when you integrate sine, you will get uh, plus minus plus. Then we have to integrate dx of x into 1. So that we have to just integrate sine kx twice. If we do it once, it will be minus of cos kx divided by k. So we have 1 k there. And then when we again integrate it, we will get 1 k. So I suggest all of you to create bracket that it's important. But then it cannot take so much of time to do it so much detail. Excruciating we can sometimes prepare to use time to walk out the problems in such a way so that we can do it. So let's get almost done. We have so this is 2 divided by 3 divided by. So what next is just putting the limit. So put 1. Okay, let's put 1 throughout. If we just put 1 throughout, this part actually becomes 0. And if I put 0 throughout, it is 0. There is an kx, sine 0, there is an x, so it becomes 0, sine 0. So they will just put the upper limit, it will become 0. Limit 1 is here, square 1 minus 1 square is nothing but 0. So lower limit put करना plus 2 divided by k. I'm just putting 1. So, minus of x is 1. Cos of k divided by k, and then we actually have it as 1 plus of sine of k into 1 divided by. So I think we could actually consider that. And to simplify further, this is a minus sine k, maybe I can take as a minus sine into. So this is like minus 4 because the minus sine we have related of theta, and then I can just take the LCM here. So I am not taking the field vector, I am just noting it. If we take the LCM here, this will be k square, so this will be k cos k. I have taken already the minus sign out, so this will be k cos of k, take the LCM. Then I have taken the minus sign, so it will be minus of divided by, we take the LCM k here, and then there is a k there, so it is again nothing but k. Okay. So that should be your correct answer. So one wrong step, one wrong calculation, integration, and entire answer is wrong. Okay. And for me, I have not even taken a single example until now. But for me, if I am giving you a question on classical mechanics, you are doing the steps correct, somebody exact mistake, and then you get the final answer wrong. Probably the chances are that I have given some mark. But mathematics is everything depends on what you get in the final answer. And if there is one single step, everything after that becomes wrong, right? It's just like that. So in a way, you have to be very careful that you take your Fourier transform correct. If you get your Fourier transform correct, then only you can get your universal Fourier transform correct. Else, it will be very difficult for you to find out. So now we are going to prove whatever is written. Okay, so while inverse Fourier transform, we are just going to do it. Okay, let me just put it down. 1 divided by root over theta. It's more or less the same. We usually do once. So e to the power I x minus k. Okay, let me just put down the value of x here. K is minus of 4 divided by root over theta into k of k minus k divided by k. If it is equal to, we have got 1 by square, and then it can be. Then we put the limit. So here, if we write this, I'll get the cos ax plus I sin ax. This part will become 0. Because on this side, imaginary part is 0. When you write down in your example, give the half one while you have, deleted the sign part because of the sign part and you have to define it here. And then the writing will down. I'm going to just simplify it now. Minus 4, I can take it out. 2 pi, 2 pi will become 2 pi. And minus infinity to plus infinity. I will just set a cos kx from here, cos kx. And then we have got k cos k minus k divided by k square into b is equal to 1 minus x square and 0. So just take care of writing this. So we are looking to the question. This is the one thing that we actually have to prove that this term is minus of 3 pi divided by 16. Okay, so let's try doing this now. Okay, so what we do now is x. Okay, this is small mistake. Okay, what I can do now is you have to actually prove that cos of x by 2. Why is there cos here? This cos here. You have a cos x here. So x by 2 I cannot have it directly. So what you do is you directly put the other changes that you have to do. Put x is equal to half. The b term is basically k, so it doesn't affect anything. So what you can do is you can just put x is equal to half. That is just simply write it out. It will get cancelled. Minus of 2 by pi integration of minus infinity to plus infinity cos of x by 2. Okay, and then we will have the derivation 3 cos k minus 9k divided by k cubed. So these are the adjustments that we have to do. It's important. Is equal to now you see this is 0, forget about this. 1 minus x square, so I'll just take it to be 1 minus square. So that's how I have to change that. Okay. So if you just do it, like this, 1 by 4, so 4 minus 1 is 3, 3 by 4. So that's it. Okay, we have this now. Now we can actually do further. If you just look into the solve way to prove, it's not k, it's x. It is also x. So what we can do is we can now do the next step. Put k is equal to x. So if that is the case, we say dk is equal to dx. And then I can just write it down to be minus infinity to plus infinity. Cos of x by 2. This is x cos x minus sin x divided by x cubed dx is equal to 3 by 4 into this is pi by 2, so it is 3. 3 by pi will become pi by 2. There is a minus 1 space, and this minus 1 will be. So we will write it down as minus of 3 pi divided by 2. Now if you look carefully, it's almost done. Okay, the only thing is the limit here. Okay, so it's basically nothing but you can just change it from 0 to 2. Okay, if you just do it, you'll see that this will be actually plus. Okay, so you can separate this out in a sign odd by odd. Okay, so if you do it, you can still get it. If you don't do it, then you can directly write it down. Minus infinity to plus. So you do it in 0 to infinity, that is actually what is x. Okay, and this is whatever is x by 2 x cos x minus sin x divided by 2. If you look at this bracket term, this entire term is actually a given term. Equal to minus of 3 pi, and I will just delete this to on this side divided by